All right, folks, we're into 5.1a, circumcenters. This material is not in 5.1 in your textbook. This is supplementary material. Think back with me to the first time we saw the circumcenter of a triangle. We did this Euclidean construction. We said put the pointy side of the compass on A, extend the length more than 50% from A to B, and draw the half arc. Then put the pointy side on B and make the symmetrical half arc. From there, we can create the perpendicular bisector of AB. All right, then we put the pointy side on B, go more than 50% of the way to C, and we create the half circle arc. Put the pointy side on C, create the other half circle arc, and then from there we can create a second perpendicular bisector. Where these two perpendicular bisectors intersect, right here, this is called the circumcenter. Then if I extend my compass from the circumcenter to A and I start spinning, I will circumscribe a triangle going through C, B, and A. We go through C, B, and A, and the triangle's in the interior. Okay, so how can we get the circumcenter not using Euclidean construction, but using something more modern? We are going to get today the circumcenter by using Descartes' Cartesian coordinate plane and some algebra. So let's get started. First thing we have to do is draw the triangle. We have a triangle at 3, 1 as first order pair, 3, 5, that's our second ordered pair, and then 9, 5, that's our third ordered pair. Connect the dots. Great. We notice this is a right triangle, but what we really are thankful for is that we have a horizontal line from B to C and a vertical line from A to B. Whenever we have a vertical or horizontal line, this type of problem becomes quite easy. First thing we have to do, we need to find the perpendicular bisector of AB. All right, what is the midpoint of AB? It's 1 plus 5, which is 6, divided by 2, which is 3. So the perpendicular bisector of AB is going to be this line right here, the line y equals 3. That's easy. Second, we need to get the perpendicular bisector of BC. What is the midpoint of 3 and 9? Add them together, you get 12. Divided by 2, you get 6. So here is the perpendicular bisector of BC. All right, notice the equation here is going to be x equals 6. Finally, we have this circumcenter where the perpendicular bisectors intersect. How am I going to get the circumcenter? Well, this is easy. I'm solving this system of equations, but it's already solved. X equal to 6, y is equal to 3. Done. Just let's check ourselves. We go over to 6 and up to 3. Yeah, that's definitely the circumcenter. Done. See how easy this was? We found the equation of the first perpendicular bisector of AB, the second perpendicular bisector, the one of BC, and then the circumcenter. What made this problem so easy is that our AB was vertical and our BC was horizontal. Therefore, our perpendicular bisectors would be horizontal and vertical, respectively, and those are super easy to get. All right, this problem will not be easy because we will not have vertical or horizontal sides for our triangle. -1, 0, -2, -3, 7, -6. That is A, B, C. Looks like we have a right triangle, but that won't help us here. AB is not vertical, BC is not horizontal, so we have to do quite a bit of work. Let's get started. To get the perpendicular bisector of AB, we have to first get the slope of AB, which I'll remind you is y2 minus y1 over x2 minus x1. All right, keep your attention right here. We've got negative 3 minus 0 over negative 2 minus negative 1, or negative 3 over negative 1, which is 3. And it looks like the slope of AB is 3. Then we'll get the midpoint of AB, capital M, which I remind you is x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. All right, that's going to be negative 1 plus negative 2 over 2. And we got 0 plus negative 3 over 2. All right, which is negative 3 halves, comma, negative 3 halves. Let's see if that makes sense for a midpoint. Negative 3 halves is negative 1.5. So negative 1.5 by negative 1.5 is right here. And that sure looks like the midpoint of AB. So it looks like the midpoint of AB is correct. The slope of AB is correct. We're well on our way. What we really need is a point that we know is on the perpendicular bisector of AB. Okay, and certainly negative 3 halves is going to work. That point is both on AB and on the perpendicular bisector. And then the slope of the perpendicular bisector of AB, let's see. If I know the slope of AB is 3, the perpendicular bisector slope is negative 1/3, which is the negative reciprocal slope. All right. Now all we have to do, let's go ahead and put that line up there. Negative 1/3, of course, is this midpoint. Slope of negative 1/3 means go down 1 over 1, 2, 3. All right, we'll connect the dots. There's our perpendicular bisector. To get its equation, use the point-slope form of the linear equation. Y minus y1 equals m times x minus x1. Y minus negative 3 halves equals negative 1/3 x minus negative 3 halves. All right, let's convert to slope-intercept. Y plus 3 halves is equal to, let's distribute. We get negative 1/3 x. Okay, so we have plus 3 halves times negative 1/3, which is negative 1/2. All right, subtract 3 halves from both sides, and we get y is equal to negative 1/3 x minus 4 halves, which of course is y equals negative 1/3 x, minus 2. This is the equation of the perpendicular bisector. Let me record that. Y is equal to negative 1/3 x minus 2. Great. Now let's erase and start on the next perpendicular bisector. Let's get the perpendicular bisector of BC. How do we do that? Well, first we need to get the slope of BC. Let's focus our attention right here. Negative 6 minus negative 3 over 7 minus negative 2, which is negative 3 over 9, or negative 1/3. Does the slope of BC look like it could be 1/3? Yeah, starting with the point B, if I went down 1 and over 3, I'd get here. 1, 3 right here. Sorry, 1, 3 right there. 1, 3 gets me to C. Yes, I got the right slope. Let's try the midpoint of BC. All right, we've got negative 2 plus 7 over 2. We got negative 3 plus negative 6 over 2. All right, so we got 5 halves comma, negative 9 halves. Let's see if that makes sense. 5 halves is 2.5. So go over 2.5. Negative 9 halves is negative 4.5. So go down 4.5. So over 2 halves, down 4.5 would put me right here. Okay, does that look like the midpoint of BC? It sure does. So it looks like we're good so far. We now focus on the perpendicular bisector. We know that it has a point that it shares with BC, and that would be the point 5 halves, comma, negative 9 halves. We know that its slope is going to be perpendicular to the slope of BC, so the negative reciprocal of the slope of BC, so 3. Let's go ahead and just kind of graph this. Starting from this midpoint that we've graphed, let's go up 3, 1, 2, 3 over 1, and we'll make that line. Yep, that's definitely the perpendicular bisector. Y minus y sub 1 is equal to m times x minus x sub 1 is the equation. Y minus negative 9 over 2 is equal to 3 times x minus 5 halves. Convert to slope-intercept. Y plus 9 halves is equal to distribute 3x minus 15 halves. Subtract 9 halves from both sides. Y is equal to 3x minus 24 halves, or y is equal to 3x minus 12. All right, let's record that. This is y is equal to 3x minus 12. Let's clear up some more space for step 3. We need to find the circumcenter. Our goal all along, to find the circumcenter of our triangle ABC. How do we do that again? Well, we set up a system of equations. Y equals negative 1/3 x minus 2 is the equation of the first perpendicular bisector. Y is equal to 3x minus 12 is the equation of the second perpendicular bisector. All right, we solve the system algebraically using either substitution or elimination. Let's try substitution. It's quite easy in this case. If y equals y, then negative 1/3 x minus 2 is equal to 3x minus 12. Let's bring the negative 1/3 x to the other side by adding negative 1/3 x, in which case you're going to get negative 2 is equal to, 3x is 9x over 3, or 9/3 x. You're going to add 1/3 x, you're going to get 10/3 x, okay, minus 12. Let's bring the 12 to the other side by adding 12. So we get 10 is equal to 10/3 x. Now we need to solve for x, so let's multiply both sides by 3/10. So you get x, we get x, and we get x equals 3. Do I have my ordered pair? No, I have half an ordered pair, so I'm going to plug 3 back into one of these equations. Let's plug it into y is equal to 3x minus 12. Y equals 3 times 3 minus 12, which is 9 minus 12, so y is equal to negative 3. Therefore, my circumcenter has the ordered pair x equals 3, y equals negative 3. Let's see if that makes sense. Let's go over 3, down 3, and we get right here, which seems to be the circumcenter, the intersection of the two perpendicular bisectors of the legs of the triangle. All right, we've succeeded. I just want you to take note of the difference here and the similarity here to the previous problem. In the previous problem, we also got the equation of the first perpendicular bisector and the equation of the second perpendicular bisector and the circumcenter. But getting the equations was easy, solving the circumcenter system was easy. Here, getting the equations of the perpendicular bisector took many steps, and then solving the system of equations involved either substitution or elimination. You can do this, folks.